We're guessing astronomers had the greatest Christmas ever, since they got the best present of all. Nearly $10 billion spent, after decades of planning, engineering, many delays, and considerable controversy. The most powerful telescope ever built was eventually completed. The James Webb Space Telescope, or JWST, is intended to be the successor to NASA's Hubble Space Telescope, which is already in orbit above the Earth, and it has the potential to profoundly change the way we examine the universe. So, what is the purpose of the James Webb Space Telescope, and why should you care about the telescope? So, only hours after announcing December 24th as the anticipated launch date for the James Webb Space Telescope, the mission was postponed to December 25th, owing to bad weather conditions, and the mission eventually took place on Christmas. The telescope, a collaborative initiative of US, European, and Canadian space agencies, was launched from Earth on December 25th. But that was only the beginning of a 6-month effort to prepare Webb to picture the cosmos. It's incredible to believe that the concept for the Webb Space Telescope was initially presented in 1989, before the Hubble Space Telescope was ever deployed. During the 2001 Decadal Survey, the massive foldable telescope was formally suggested as a near-infrared workhorse capable of probing anything from exoplanetary systems to the very early cosmos. NASA has spent nearly 3 decades developing this telescope and getting it to the launch pad. The telescope has now been launched on top of a European Ariane 5 rocket from Europe's major launch facility in Kourou, French Guiana, South America. However, once the telescope gets in orbit, there is still a long way to go. Because the JWST is so large, it must go to space folded up. So, we'd begin with what the purpose of this telescope is. JWST is intended to focus on the infrared region of the spectrum ranging from 0.6 red light to 28 microns infrared. This implies that, unlike Hubble, it will not be able to see in ultraviolet light, but will be able to focus on infrared luminous objects, such as extreme distant galaxies. These pioneer stars are expected to have exploded 100 to 200 million years after the Big Bang, or a little more than 13.5 billion years ago. Webb will be looking for clusters of these stars. They are so far away that even if their light travels at 300,000 kilometers, 186 miles per second, it will take billions of years to traverse the galaxy. The telescope will be able to see almost everything in the sky. It does, however, have one overarching goal: to view the light emitted by the very earliest stars to shine in the universe. The first thing to know about JWST is that it is enormous. The telescope has a light-collecting mirror that is almost 20 feet, 6.5 meters, wide. Hubble's mirror, by comparison, is just under 8 feet, 2.4 meters broad, and has been responsible for photographing some of the most iconic objects we've ever seen in the universe. JWST will be 10 to 100 times more sensitive than Hubble due to its bigger mirror, allowing it to detect very faint objects in the sky. JWST's engineers had to create this gigantic mirror in sections to put it together. It is composed of 18 hexagonal pieces of the lightweight element beryllium, which is about the size of a coffee table. The segments must nearly completely line together, moving so accurately that they are positioned within a portion of a wavelength of light, which is roughly 1/10,000th the diameter of a human hair. One distinguishing aspect of the mirror is that it is covered with a coating of gold that is 200 times thinner than a human hair. The gold allows JWST to view in the infrared, a form of light associated with some of the universe's most distant galaxies and stars. Because the universe is expanding, the furthest things from Earth are moving faster than the ones closer to us. So, what distinguishes Webb from other space telescopes, and what makes it a big deal? The Webb Space Telescope, named after a former NASA administrator, outperforms its predecessor, the Hubble Space Telescope, in 2 critical areas. The first difference is simply size. Hubble is around the size of a school bus, whereas Webb is roughly the size of a tennis court. This thing is huge, Amber Strawn, a NASA astrophysicist working on the Webb, said earlier this year. By far the largest telescope NASA has ever attempted to put into orbit, says Webb. It is far larger than the Hubble Space Telescope, which has been circling Earth since 1990. We'd want to compare the size disparities between Hubble and James Webb now. The Hubble Space Telescope has a length of 13.2 meters, 43.5 feet, and a maximum diameter of 4.2 meters, 14 feet. It's around the size of a huge truck. Hubble's aperture, the piece of the telescope that can receive light, is 2.4 meters wide, and the telescope is 13.2 meters, 43.5 feet long, with a maximum diameter of 4.2 meters, 14 feet. It's around the size of a huge truck. Hubble's aperture, the part of the telescope that can receive light, is 2.4 meters wide. As you can see, the JWST will feature a large sun shield to assist keep it cool. Webb is around the size of a tennis court, with all of the related equipment. It's so large that it has to be folded in order to fit inside its launch rocket. The important feature of Webb is that it can detect light that Hubble cannot, in the infrared. The light is undetectable to human sight, yet it is the sort of light in which the glow from the universe's farther distant objects may be seen. Light comes in a variety of hues. The human eye can only sense a narrow band of light known as visible light, but the universe contains a broad spectrum of light beyond this range, including higher frequency, high energy forms such as ultraviolet, X-rays, and gamma rays. Then there's lower energy light with longer wavelengths, including infrared, microwaves, and radio waves. The Hubble Space Telescope catches visible light, ultraviolet light, and a little amount of infrared radiation. Because the Webb is essentially an infrared telescope, it perceives light with a longer wavelength than our eyes. This may appear nerdy and complicated, but it is what permits Webb to view further back in time than the Hubble. Because of a process known as red shifting, infrared light is frequently extremely ancient light. When a light source moves away from an observer, it stretches out and morphs into longer and longer wavelengths. Because space is always expanding, the objects that are the furthest away from us in the cosmos are also moving away from us. This is why the Webb is being launched at such a great distance. Webb must be kept cool because it is an infrared telescope. The Earth itself is heated and emits infrared light. So how much did Webb cost? And why was it so expensive? NASA spent $8.8 billion on Webb's design and construction, and it will invest another $860 million to sustain the mission for the next 5 years. This amounts to $9.7 billion in US dollars. The European Space Agency has contributed around 700 million euros to the project, funding 2 of Webb's 4 instruments and providing the Ariane launch rocket. The Canadian Space Agency, CSA, also contributed around £120 million. It all adds up to more than $10 billion. True, Webb is years behind schedule, and it has suffered from terrible project management several times. However, some of the funds were spent on technological advancements that have broader applications elsewhere. So, can astronauts assist Webb? No, it will be too far away from Earth for astronauts to explore. Even if they were able to reach Webb, its architecture prevents instruments and other worn-out equipment from being changed, as they were when NASA personnel visited Hubble aboard the space shuttle. Webb will have a fuel supply that will maintain it in orbit for at least 10 years. It's not totally out of the idea that its fuel tank may be replenished by a robotic vessel in the future, but this isn't part of the current plan. However, launch is only the beginning. The next several days will be crucial in determining whether the new James Webb Telescope will be able to carry out its exciting objective of imaging the earliest stars to light in the universe. The Space Observatory is going to attempt to unpack its 5-layered solar screen, which has put into orbit on launch day. As previously noted, the telescope requires extremely cold temperatures. Webb cannot attain the super cold temperatures required for its mirrors and sensors without the tennis court-sized barrier. A simplified description for how the telescope will operate as we know, it has already launched, thus the deployments of the solar arrays would come next, followed by the deployment of the sun shield pallets, according to the timetable we are now on. The sun shield deployment procedure is expected to be completed by January 3rd. However, each stage of the deployment sequence is controlled from the ground, and the timeframe can be altered as NASA and its partners see fit. After that, the sun shield insulation layers will be separated, followed by secondary mirror deployment, and then main mirror deployment. There is a lot that goes into this process, and all we can do now is sit back and watch the world's greatest telescope. What are your thoughts on the telescope? And what are you most excited to see from it? Please share your thoughts in the comment section below.